One really nice aspect about developing a single page application is that your API requests kind of have logging built in. Because they happen in the client, in the browser, you can inspect the network tab and drill in, see the payloads, the responses. It's all super convenient. Well, you kind of lose all of that whenever you move to something like Remix or React Router. All that is happening in your actions and loaders behind the scenes. So one way to get around that is to explicitly add logging. And so if I click around and your logger or your actions and loaders are set up to log that stuff, it can look like this, which yes, it's there, but it's super hard to read. Not very friendly to deal with. So what if we could ship these JSON logs and have them show up in the browser console? I think that would be much more useful. And also, what if we could format them really nicely? It could look something like this. Click around. These are API requests that are happening in the loaders. I can update a record. Hey, Kent. Clear this, save it. I can see the put request that's going on in my action. I can drill into this, see the payload that I'm sending to this endpoint and the response that I get. But what if you're not using API requests? What if you're using something like Prisma? Well, let's see what that might look like. Click around, fire some actions and loaders, and we can log the queries and their arguments. So let's say I update this record. Hey, Christopher, this issued an update query, and these are the params that I get, or that I sent. That's so much more useful than staring at this. This is what I want to show you how I built, and it's not that complicated. Okay, so this is the React Router address book tutorial at its completion. And this is what we're going to build this functionality into. So if I click around, actions, loaders get fired, but I don't see anything. Nothing is getting logged. It's literally the end of the tutorial. So that's where I want to pick up. Okay, so first things first, let's create a new directory, a service directory with a singleton server TS file. Sure. And then I'm going to paste this in. I copy this from another project, and basically this is a global object that's attached to the global object, or that's not the window because this is a node, but the global object. So this lets us define things and attach them to the global object, and then they will persist between hot module reloads. So there can only ever be, we can define services on this thing, and when we retrieve them, it will always be the same instance. Okay, next let's add a logger. Okay, I want to use Winston, a very popular logging library. Okay, and then let's grab this. Oh, I forgot. So let's fix, I want to be able to import from this squiggly, so let's fix that. In our TS config, we can add this path alias for the squiggly to point to app, and then to make this work, we'll pull in this TS config paths package, and then we'll copy this in and run that. There we go. Okay, so back in our logger server file. Very simple. We're importing the singleton, where the first argument is an arbitrary name, so a key. So we'll just call it logger, and then the second argument is a function that returns a value that we want to live at this key. So in this case, I'm creating a logger, setting the log level based on the node environment, and then the only transport we're using is the console. It just logs to the console. Winston has a ton of other transports, obviously to a file, to an HTTP endpoint, or you can implement your own. Okay, so now that we have that, let's try to use it in our fake database that the Address Book tutorial comes with. So let's do contact, and then just inject something in here whenever we get a contact. Logger info fetching contact, and then the second argument will be some metadata we want associated with this log, and then we'll just attach the contact. Let's import this. Okay, now we'll go to here, click around, and we'll see some logs. Perfect. Okay, we're almost there. Okay, so next we need a way to ship these logs to the browser. And this is what I want to use server sent events for. What are server sent events? They're like WebSocket's cousin. Whereas WebSockets, you can send and receive messages. Server sent events, the server can only send messages, which is exactly what we want to do. We want to have our server send messages to the browser. Okay, so what do we need to do to get that working? We'll define another very simple service called the emitter. It's also going to be a singleton, and this comes from Node. The event emitter basically is just a way to fire arbitrary events on it and then have something listen to it and do something with those events. Okay, so now we want to update our logger to fire or dispatch logging events on this thing. So what we need to do is install Winston transport, which will let us define a custom transport. And in here, we'll import the Winston transport package, the emitter, and then here is our custom transport. This is all it is. This little bitty class that extends transport has some boilerplate, has one method, the log method. In it, you get the info is the log object that gets generated whenever you actually perform a log, and then a callback. So I just looked at the docs, but this is the boilerplate, this is boilerplate, and this line is what I added to create this, to make this work. And basically all we're doing is we're getting a hold of the emitter, we're firing a log event, which the event name is arbitrary, and then we're just JSON stringifying this info object. So any log that comes in is gonna get JSON stringified and gets dispatched on the emitter. So now we need to add that to our logging instance. So if we're not in production, we're going to add this new emitter transport we just created, because we don't want to do this stuff in production. This is just for development. Okay, so now all our logs are in development being dispatched to this event emitter. So now what we can do is we'll define a new route. And at this point, I'm going to pull in remix utils, which is an awesome library from Sergio. Super useful stuff in there, but we're just going to use one thing, and I'll paste this in. And then we also need to add this to the routes so our type gets generated. So adding a route at the logs path, and we're pointing to this new logs.tsx. Now if I pm run dev, that should get built, that should go away, yes. And here's our route. So this is like a resource route. The only thing we're exporting is the loader. We're not exporting a component. And then in here, we only want to do this during development. So if it's not development, let's just throw an error. And then here is where we're importing the event stream from Remix Utils, passing it the request signal and then a callback. In here, we are listening to the event, that log event, which matches what we're doing right here. And we're saying on that log event, we want to send it into the event stream. And then whenever the connection closes, we want to disconnect from that event. So that's all there is to this loader. So the next thing we need to do is make use of it. So in the root.tsx file, let's do that now. I don't need to do that yet. Okay, so we're gonna use an effect, and let me copy some of this stuff in. Okay, so first we need to add a loader. Export async function loader. And then we want to say, is this logging turned on? And we'll do this based on the node environment again. Next, we can copy this. Oh, don't look at that yet. Spoilers. Okay, so what did we do? We added a flag to determine if server sent event logging is turned on. In our component, we're getting that Boolean value and then using it in this use effect. In the use effect, if it's not turned on, we're just bailing out. Otherwise, we want to connect to our new route with this event source. And this is a browser API. This isn't Remix or React Router specific. Next, we're going to define a handler function that is the listener. So once we have the source, we're adding an event listener. And again, we're using that log event name that we're using in the backend. It must match. And then passing in the handler. The handler receives an event. And on that event is the data itself. And what we're doing here is we're attempting to parse it as JSON, which it should be. Otherwise, we're just falling back to console logging it as it is. Next, we're returning a cleanup function where we're removing the handler and closing the event source connection. So pretty simple stuff. So next, let's see where we are. See if we actually have this wired up and working. So, all right, there we go. So now if we click around, our one log that we added to that the fetch of the contact is getting logged to the browser. So if we look at the network tab, we can check out this connection and actually see these coming across. And again, this log name must match everywhere where dispatching and listening to events. And this is the data can be a string, and we're just happening to send JSON that we can parse back out in the browser. Okay, so now let's pretty this up a little bit. One of the cool APIs that comes with Chromium is the ability to add custom object formatters. If you have any experience with Redux and or Immutable.js, you might have installed the Immutable.js browser extension, which makes use of this concept. But we're going to implement our own. So let's define one in a dev directory, simple object formatter. Okay, so paste that in. Okay, so let's go over what this is. So let's start here. So in Chromium, there is this DevTools formatters thing. In here, if we don't have it, we're just defaulting to an empty array. Otherwise, and then we're pushing a object formatter onto it. So what is an object formatter? An object formatter is just an instance of a class that has at most 3 methods. The header, let's start there. The header. So what's the header? Whenever an object gets logged, like say you're logging a huge object with a bunch of different fields, the browser doesn't just automatically expand that out. It shows you a truncated version of it as the header, and then you can expand to see the body. So this header is that shortened version. So in here, you determine whether this formatter even applies to this object that is being logged. So if we go back and view our messages, we see that level and message are coming across. The level is the log level, and the message is just the string that we put in that logging call. So in here, I'm saying, hey, if we have the level and a message, or if we don't have it, we're just going to return null. This object formatter does not apply to this thing that's being logged. Otherwise, we're going to continue on, and we're going to get the log level, or the color from the log level. And this is just a map with some colors defined, with some log level keys, so easy stuff. And next, we're going to return some elements. This is very similar to how React looks if you're not using JSX. So elements are represented by arrays. The first item in the array is the tag. The next is properties of that element. And then the remaining items are the children, which can be arrays of more elements. So this is a simple example. So if you just pay attention to this, we have a span, we're adding some styling, and then the children is the message itself. So for this one, we're wrapping this in a div. The first span is the bracket and the uppercase level. Next, we're giving it some padding, and then spitting out the log message itself. And then everything else, what's left, we're putting into this REST object and checking if there is anything. And then we're going to log a reference to that object, which will show up as like what you're used to seeing whenever you console log an object. So now, how do we make use of this? So let's go back to the root. And import it. And we're going to add, you'll notice that we didn't write this in TypeScript. This is just plain old JavaScript. And I'm doing this so I can add this raw tag. And so what that does is it gets the JavaScript as a string, the script itself. So now in my loader, I can return those formatters based on whether server-sent logging is turned on or whether we're in development or not. Defining a custom object formatters key and then setting that to an array of scripts. So if it's in development, I'm going to pass the simple object formatter that we just came up with. Otherwise, it's going to be an empty array. So now in the component, I'm going to grab that out, the loader data. I'm going to move this into a fragment. And then here I'm checking if we have any formatters. If the length is greater than 0, then we're going to insert a script tag and dangerously set the HTML to the script itself. So now we just need to enable custom formatters. So to do that, we can go over, pop open the DevTools, click this cog icon. And in the console setting, at the very bottom is a custom formatters checkbox. Just got to make sure that's checked on. And now, we got some fancy styled logging going on. So why am I doing it this way? Well, by doing it this way, I guaranteed that this code will never get, well, I'm not guaranteed, it's up to me, but I'm not automatically putting it in the client. I determine if it gets sent, and when it gets sent, it's coming from the loader. It's not automatically in a client bundle somewhere. Let's add a API formatter. This one's a little more complicated, and I'll show you what that looks like. Here we go. Let's replace our simple log call, and we'll replace it with a bit more complicated. We'll just fake a number. Well, actually, let's actually implement that. So let's define another service. We'll call it profile. All right, and then in this, you can ignore this for now. It's kind of a handy function to time things and have it return. You pass it a callback and it'll time the callback. It gives you the return value and then how long it took in milliseconds. The other function that I'm exporting in here is just a way to generate a random number. So back in our data file, let's use that and just give it a range of, let's say, 100 milliseconds to 200. Pick a random number between them. Okay, so what are the interesting bits here? So again, the first argument is the log message, and then the next is the metadata of this log. And here, we're kind of faking an API request. I know we're not actually making one, but pretend we are, and this is what we got back. It was a GET request This is the endpoint we hit, status, and a response, and how long it took. The other interesting bit is this double underscore type property. And I just made this up. This is just a way for you to identify objects that you can apply custom formatting to. So in the API object formatter, the header is explicitly checking this type for that API value. If it's not there, this object formatter doesn't apply, so it's just going to bail. Otherwise, we're going to define the header, and then the other two methods that I mentioned earlier are hasBody and body. So the hasBody determines whether or not you can expand the object in the console. So in here, I'm testing if the object has any of these three keys, and if so, I want to make those the body of that log. And this is just more elements, how I mentioned earlier. Pretty simple. If we have a message, add a message element and the message itself. If we have a payload, add a payload field and then print the payload object. And same for the response. And then we're also doing the same thing here where we're pushing it onto this DevTools formatters. So now we need to add that to the root. And tack it on here. Reload the page. Oh, maybe I need to... Yes, the order matters. Let's switch these around. There we go. Okay, so the API object formatter needs to come first, so it will apply. So now, if we expand this, we see our message and our response we got. If we update it again, oh, I haven't implemented all the other ones, like in the demo I showed earlier. So yeah. In my demo, I also have a query object formatter. It would look something like, pretend you weren't making an API request, and instead you were using, talking to the database directly. Do the same thing. Add a type of query, the query itself, any params, and data you get back from that query, and how long it took. And you can format it however you want to. And Prisma even shows you like how to listen to queries and log them yourself. So you could just do that right here. And that's what this is. Again, so much more useful than staring at the the logs in the terminal. And what's great about this is you don't have to bundle it up in an extension to distribute to your team. You can write the code in your repository, and it's implemented out of the box for everybody else. There's no extension you got to install. There's nothing you have to do. You just put it in your app. You have complete control over it, which I thought was really nice. Anyways, I thought this was really cool. It's super useful for me. I thought I'd share. I published this repo that's public. It's the address book tutorial. So there's two branches. The main branch is the completed tutorial, and and then the SSE logging picks up off from that branch and adds all the stuff that we did throughout the video. Also, I have a blog at programmingarhard.com where I publish React Router and Remix related stuff and other web things that I find interesting. I have a newsletter I'm starting, so if you find the stuff useful, feel free to sign up. There's a few things I encountered whenever I was doing the server sent event stuff, and I kind of go into a deeper dive in the blog post version of this video, like why I didn't use Remix Utils use event source hook. There's actually a pretty good reason, so feel free to check that out. All right, peace.